we are doing systems of linear and quadratic. Systems of linear and quadratic. Sketch function graphs that illustrate the possible number of solutions for equations involving linear. Circle that, please. Underline it. Involving linear and quadratic functions. Okay? So, what does a linear function look like on a graph? A line. So, draw a line. Okay? Draw a line. Any type of line. Draw a line. What does a quadratic look like on a graph?
A horseshoe.
Looks like a parabola, which is a U shape. Okay? How many solutions are there to those two functions? Two. Why? Good. They intersect at two spots. So there are two solutions to this graph. Okay? Because it's where they intersect. So if you graph two things, the solution is where they intersect. Okay? Is there a way to draw the graph a little bit differently?
Yeah.
How could I draw it? How could I make it where it doesn't have two solutions? How would I draw my straight line? All right, I could draw my straight line up and down. Good. If I draw my straight line up and down and then I draw my parabola, how many solutions does that one have? That one has one solution. Okay. That one has one solution. Okay. What about the third option? Yep, no solutions. How would I draw that?
You can draw a parabola and put a line under it or something beside it.
Okay, so if I draw my parabola here and my linear function here, this one has no solutions. Okay, no solutions. Okay, questions? Okay. First one says solve by substitution. Okay, solve by substitution. We know that y equals x squared minus 6x plus 6. We kind of did this the other day. We're going to take this and put it in the y spot because that's what y equals. We're going to take x squared minus 6x plus 6 and put it in the y spot. So I'm going to write x squared minus 6x plus 6 minus x equals negative 4. So I put what was in the circle in the y spot, and then I just kept writing the equation. Minus x equals negative 4. Okay? All right, how many variables does this one have?
1, 2.
All right, it's got an x squared and an x. When it has an x squared and an x, we have to do the quadratic formula, the A, B, C thing, okay? The problem is before I can label A, B, and C, I need to put some stuff together. Is there anything to put with x squared? No, so we'll drop it down. Okay, drop down your x squared. What about negative 6x? Put negative x with it. They're on the same side. Put them together. Negative x minus 1. I'm sorry, negative 6 minus 1. Negative 7x. Okay, so I'm putting those two together. And one more thing I can do. Very good. I see some people already doing that. Moving to negative 4 so it becomes positive 4. And what do I do with that positive 4? Add it with the 6. Good. Add it with the 6. So now I do A, B, C. All right, now I do A, B, C. And what formula do I do with that? Opposite of B. Opposite of B. Plus or minus square root. Plus or minus square root. B squared minus 4AC all over 2A. Okay? All right. So 7 plus or minus the square root of 4, parentheses 1, parentheses 10 over 2. Very good. Thank you to those of you getting out your calculators and doing it without me asking. I appreciate that very much. So 7 plus or minus, they're typing in, those of you who have been absent, what they're doing, they're typing in this parentheses negative 7, parentheses squared, minus 4 times 1 times 10. You're typing in just that. Type just that in your calculator. Don't type in the square root. What are y'all getting for the number?
9.
And then on the bottom, 2 times 1 is 2. Okay? Anybody disagree with the 9? Okay? Do I leave my answer like that? No. 9 breaks down to... All right, so guys, do I put the square root of 3 or just a 3? Just a 3. Just a 3. If you circle it, it's not left inside. These two people, they had somebody to go to the movies with, so they're not stuck at home anymore, okay? And then remember, you have to do one last step on this one. 7 plus 3, 10 divided by 2. 7 minus 3 divided by 2. Okay, so that is one way to do it, okay? That's one way. For number 2, instead of doing it by hand, this is how you do it by hand. For number 2, we're going to put it in Desmos, okay? So for number 2, we're going to put it in Desmos. So go ahead and pull that up on your computer. And type it in. Start typing, please. Yes. Guys, there will be Desmos on your final exam.
I have a question.
Are y'all typing? Everybody typing in their computers, typing in Desmos. All right. X plus y equals 1. X plus y equals 1. And 2x squared minus 4x equals y plus 1. Okay? Yeah, my TV is messed up. Okay, so, guys, do you have it in Desmos? Does yours look like mine? Okay, so we click where they intersect. So right there is one of the answers, negative 0.5, comma 1.5. Okay, so let's write that down. Yep, you write the point. Negative 0.5, comma. Guys, what was the point?
It's negative 0.5 and 1.5.
Okay, that's what I thought. Okay. Negative 0.5, comma 1.5. And then there's another answer, right? Then you click over here where it intersects as well. It intersects at 2, comma negative 1. Okay. Yes. Where they intersect. Just where they intersect. Okay, just where they intersect. And guys, actually, so I assume most of y'all will not be doing it by hand. However, just to, I should have told you that if you do it by hand, are 5 and 2 your x values or your y values? Those are x's. X equals 5 and x equals 2. And so if you're taking a multiple choice exam and you see points, you would have to plug this back in to get the y value. So right here, if I plugged in a 5, you plug it back into the original. What's 5 squared? 25. Negative 6 times 5 is 30, so it'd be 25 minus 30. That's negative 5 plus 6, positive 1. So it'd be 5, comma 1 if you did it by hand. Then if you plugged in a 2, 2 squared is 4 minus 12, negative 8, right? Plus 6, negative 2. So that's how you would get the points if you were doing it by hand. Okay? 5, comma 1, and 2, negative 2. Okay, number 3, do you want to do it by hand or do it in Desmos? That's what I thought, okay? So number 3, let's type it in Desmos. Remember, alternate who's typing. Negative 7x plus 3y equals 3. Okay, is y'all's looking like mine? All right, so I'm going to zoom out just to double check. Are they ever going to cross? No, they're not ever going to cross. So the answer to this one, what do you think?
No solution.
Very good. No solution. Okay? So the answer to this one is no solution. Okay? Okay. Number 4, Amir solved the following system of equations and found the values of x. To make those be true, which statement best describes the reasonableness of these solutions? Okay? A says the solutions are unreasonable because the solutions cannot be fractions. Before I can choose an answer on this one, what do you think I should probably do? Yeah, plug it into Desmos. Let's go ahead and put it in. And guys, remember, if you get tired of typing, we can always do it by hand. If you get tired of typing, let me know. We can do it by hand. All right, so you put it in Desmos. So x squared minus 10x, thank you, plus 23. And then 1/5 x, thank you, minus 3. All right, guys, look up at the screen real quick. Even if you're typing, look up here real quick. Just by looking at it at first glance, how many times does it look like they touch? Once, okay? And this problem, this came straight from the state test bank, okay? They love to make hard problems, right? Tricky problems. If you zoom in, how many times do they cross? Twice, okay? So you've got to be careful. You need to check your zooming in and zoom out because they like to give you hard ones, okay? So we've got, one of them is 5.2 and the other one is 5. Do y'all see that? One is 5, one is 5.2. And so let's look at, the solutions are unreasonable because the solutions cannot be fractions. Have we ever said solutions cannot be fractions? No, okay? The solutions are reasonable because both values make the linear equation true. That sounds like that might be right, so we might come back to that. The solutions are unreasonable because the graph of the linear equation can only intersect the graph of the quadratic equation at one point. Does it only intersect at one point? No. Okay. The solutions are reasonable because the graph of the linear equation will intersect the graph of the quadratic equation at 5, -2. 26 over 5. I wonder what that is. So let me use my calculator. I have both tools available, so I should use them. 26 over 5. Sorry, I'm trying to get where y'all can see this. All right, 26 over 5. Type it in, and what does it give you? 5.2. Okay, so this is 5.2. All right, what's the better answer, B or D? D. Okay, D is your better answer on that one. Questions? All right, flip it over. Rochelle will launch a model rocket from the ground. Serena will hold a laser light 2 feet above the ground and point it in a path of the rocket. The height y in feet of the rocket can be represented by the equation y equals -16x squared plus 32x, where x is the time in seconds. The graph below represents this situation. So they've already graphed it for you. What is the parabola showing you? The height of a what? Of a rocket. The rocket goes up and then it comes back down. What's the linear line showing you? A laser light, okay? The equation that represents the laser light is that. What times most closely approximate when the laser light will strike the rocket after its launch? Okay? All right, let's look at a 0.07. 0.07. Is 0.07 between 0.6 and 0.8, or is that less than 0.2? Think about it as far as money. How much is 0.07 in money?
Like
7 cents, okay? What is 0.2 in money? 20 cents, okay? This is 20 cents and that's 7 cents. So right here, that's one of the places that the rocket strikes the laser light. Could that possibly be at 0.07? Yeah, it might be. It could be at 0.06. We don't know. Is it at 0? No, that's not at 0. 0 is down here. Okay, so we can mark out D. All right, let's go to the next answer choice, 1.76. That's $1.76. So we're looking at this other point, and it looks like, could it be at $1.76? It could be. Let's look at the next answer choice, B. That's at 1.9. Is it all the way at 1.9? No. What about 2.1? No. So what's the best answer? A. A is the best answer. Okay. All right, number 6, what are the y coordinates of the solution of the system of equations 5x minus y equals 3, 2x squared plus y equals 0? Okay? What am I going to do with these two equations? Put them in Desmos. Go ahead, start typing, please. Whoever's turn it is, start typing. Okay, so I'm going to click where my black one and the purple one intersect. 0.5 comma negative 0.5. That's one of them. You've got to be really careful on this one as well. Is there anything that I should have paid attention to in the problem? Very good. It's asking for the y coordinate. It's asking for the y coordinate. So if I go back to my graph, the y coordinate is at positive 0.5 or negative 0.5? Negative 0.5. So I need an answer choice that has negative 0.5. What's 0.5 as a fraction? 1/2. So I need an answer choice with negative 1/2 in it. So A. Okay. Where do they get the negative 18 from? Yep. If you pull your graph down and click the other one, there's negative 18. Okay. All right, great. Number 7, which graph shows the solutions of the system y equals x squared plus 2 and y equals x plus 4? Once again, you can type both of those into Desmos. If you wanted to go ahead and eliminate some by using your head, the 2 is your what? Y-intercept. So, and the x squared means it's going to be a u. So I need the parabola to go through 2. That one does. Does this parabola go through positive 2? No, so I can mark that one out. Does this parabola go through positive 2? No. What about the last one? Yes. Okay. And then if you look at your linear function, what's your y-intercept? 4. So it should go through positive 4. Does your linear one go through positive 4 here? Yes. Does your linear one go through positive 4 here? Yes. All right, without using Desmos, what else do I know about this line? It has a positive slope of 1. Which one, A or D, has a positive slope? A. Okay? But you could use Desmos if you wanted, but that's how you would do it without Desmos on that one. Okay? All right. Number 8, the sum of two numbers is 24. The sum of the squares of the two numbers is 306. What is the product of the two numbers? All right, I got 2 pieces of information. I've got 2 pieces of information. The sum of the two numbers is 24. The sum of the squares of the two numbers is 306. So I go ahead and make 2 equations. What can I do for the sum of the two numbers is 24?
X plus y.
Good. X plus y equals 24. X plus y equals 24. What about the sum of the squares?
Is it x, y plus 2?
Close. If I square x, what do I write? X squared. Okay? And sum still means to add. What do you think I'm adding x squared to? All right, so the sum of the squares, so it's x squared and y squared, okay, equals 306, okay? So you got to write your two equations, and then you can put them in Desmos, okay? All right, make sure you got it typed in, please. Guys, remember if you hit this house button over here on the side, it makes it go back to the original, and then you can zoom out or in if you need to. Okay, how many times does this one touch? Twice. This one says 9, 15, and this one says 15, 9. Let's see which one I should choose. Let me go back and look at the question. What is the product of the two numbers? What's product mean to do? Multiply. Product means to multiply. So we said the two answers were 9, 15 or 15, 9. Does it matter which one I choose? No. What I need to do is multiply 9 times 15. No matter how you go about it, you need to multiply 9 times 15. What is that?
135.
Say it again. 135. Okay? All right, last one, number 9. Consider the equation x squared minus 2 equals x. Note that the left-hand side of the equation is a quadratic function and the right-hand side is a linear function. Name the points where these linear and quadratic functions intersect. Okay? All right, let's try typing just that into Desmos and see what happens. Last one, guys, stick with me. Type in that last one, x squared minus 2 equals x. Okay, so type that one into Desmos. You see you get this triangle over here? All right, it's not working, is it? Okay, if you go back and look at the question one more time, they tell you that the left-hand side is a what? They tell you the left-hand side is quadratic. And they tell you the right-hand side is linear, okay? And they said name the points where these linear and quadratic functions intersect. You're going to have to type them in separate lines, so that way you have two different things that will intersect each other. You're going to have to type it in. You're going to have to type in two separate functions, x squared minus 2 and x. You're going to have to type them in separately, so that you have two functions that will intersect, okay? All right, what's one of the points that you have? 2, 2, and what? -1, -1, okay?